אף אחד לא אוהב אותי.
עוד רגע, דניאל כנראה ייכנס למשך.
סבבה, אני התחלתי לצלם.
שזה כאילו, אנחנו לא סרט שעושים one shot.
יאללה, אנחנו...
יאללה חבר'ה.
Hello, Professor Dori.
Hello.
Thank you for taking the time to speak with us, and we have the opportunity to expand our horizons a little bit and discuss OPM outside of the course, because there is a lot to talk about. So I'll start right away at the beginning. How did you come up with OPM? What is the story of the invention of OPM?
So in the early 90s, when I was still assistant professor at the University of Kansas Computer Science, I was supposed to come back to become faculty at the Technion, and I was told that I'm going to teach object-oriented analysis and design, which at that time was just beginning. So I read a couple of books and got the idea that objects were the center of the thinking process, and everything centered around objects.
Yes.
And then when I came, a colleague from University of Washington visited me, and we were working on preparing a proposal, a research proposal in which engineering drawings that were done by hand were supposed to be converted to CAD systems. And we drew the processes and the things that we thought as objects on the whiteboard as boxes, and connected them with arrows and lines to express what was going on in the system, the structure and behavior and so on. But then when I looked at the boxes and what was written inside them, I realized that not all of them have the same meaning. And so I circled the ones that were not really objects as things that exist. And I got an interesting pattern of a bipartite graph where almost every box was connected to a circle. And then it dawned on me, like a eureka moment, that not all objects are the same. Some objects are quote-unquote real objects.
Yes.
And some are actually things that happen to those objects. And later on, we call them processes.
Right.
And this is how the idea began evolving. And that was like around 1992. But it took 3 years before the first paper was accepted to Journal of Logic and Computation, because people just didn't accept the idea that you can use the same diagram to describe structure and behavior. The common wisdom was and still is that you need separate diagrams, and not only two, to describe structure separately and behavior separately.
Right, so this idea of having one diagram with only objects and processes and relations between those objects and processes, that would be sufficient to model virtually any classical technological system.
And it was very hard, and it still is hard for people to accept this idea, but we are showing that not only is it possible, it is much easier and much more expressive than separating the various aspects to different diagrams, which are actually different languages.
Thank you. If you could just explain briefly what are CAD systems for those watching who might not know what they are.
Computer-aided design systems are the current way that people do design of machine parts and building layouts. But at that time, in the 70s and 80s, people were just mostly using drawing boards, and there were millions of engineering drawings that needed to be converted to the then emerging CAD systems.
Right.
And instead of doing it manually, we wanted to come up with a system that does it automatically. That was my PhD.
So, thank you. So that was the origin,
right,
of OPM, essentially during your PhD studies.
Well, that gave me the background of the case in point to model, which led to this. Yes.
To this eureka moment you spoke about, the
yes.
understanding that there aren't just objects, but there are objects and processes.
Right. And
things that are or aren't, and things that either occur or don't occur.
Exactly. And the things that occur or happen, they don't happen in vacuum, they happen to the real objects, to the objects.
Right.
But in order to understand the system from both its structure and behavior aspects, you need to put them both in the same diagram and not separate them. Separating is actually just detrimental to the understanding of the system as a whole.
Right. So separating the structure and the behavior
is not good.
Is not does not lend itself to better understanding of the system, exactly. But the opposite.
The opposite. It's the separation. At the end of the day, the system has both structure and exhibits behavior, and if
Right.
it is separated to different diagrams with different notations, at the end of the day, the person to whom this is communicated needs to do the mixture in his or her head.
Right.
And it's much better to see it visually in the same diagram and follow what's going on.
So each person in their own heads would do it obviously in their own way.
Right.
So that's not a formal representation.
There
And
is
OPM allows a formal representation of the link between the structure and the behavior, or the system architecture as a whole.
Exactly. There is a lot of unnecessary mental burden by requiring that people move in their heads from one representation to another in order to understand holistically the structure and behavior of the system.
Right.
How they relate to each other.
Thank you very much. So the next thing I wanted to ask you about was if you could pick out from a few decades of doing projects using OPM, if you could perhaps pick one project which you think stands out, that you're particularly proud of, which you can tell me about.
Yes, one project that sticks out, and also the chief systems engineer of that project keeps talking about it, even though he has retired several years now, is a project called Music, which was aimed at developing a system to defend civilian aircrafts with hundreds of passengers from being shot down by terrorist shoulder missiles,
Mm-hmm. Yes.
which emerged after a real attempt to down such an airplane. And
Just sorry to interrupt, could you tell us where and when this attempt took place?
yeah, it was I think around 2004 in Nigeria. It was an attempt of a terrorist group to shoot down an Israeli airplane with a couple hundred people.
Right.
Fortunately, it didn't work out, but that turned on a red light for the government to order such system, and the company in Israel called Elbit started developing it. Of
Yes.
course, this is a pretty big, complex and a project that involves a lot of engineering disciplines, and it started fine, but at some point in time, the whole thing got stuck and stalled, and at that point we got into the picture and we gathered all the various disciplinary engineers around the same table, and we modeled using OPM the system as it was at that point in time.
Yes.
And as we were doing this, the people around the table started to realize that they were talking the same words but meaning different things, and that's why they didn't actually have a common language that would enable them to carry on with the project. As soon as they realized that they mean different things, now they speak the same language and meaning the same thing, thanks to the common model that they were looking at and referring to. From that point on, after a few months, the project was up and running, and it is currently installed successfully in many commercial aircrafts, not just in Israel, but around the world.
Around the world. So this system was called Music, which is an
yeah.
acronym for
it's a multispectral something.
multispectral something. Okay, we'll put it in afterwards. So in effect, this story that you just told me about, and as you said, the systems engineer of that project still talks about it, is actually a exemplary case of miscommunication between domains, between disciplines, between different professionals, different engineers.
Exactly.
And OPM helped
Yes.
to bridge that communication gap by providing a domain agnostic language.
Definitely. As soon as people realize that they don't speak the same language, meaning they do speak the same words but meaning different things,
Yeah.
that really opened up the communication channel, and this is what enabled the project to eventually become successful in a relatively short period of time.
So in effect, using OPM as part of the system design process can help speed up that process.
Absolutely, not just
Because-
speed up, but also make it, streamline it, and
Streamline it, more efficient, and
absolutely, yes.
see, thank you very much. So, Professor Dori, how do you see the future of OPM, or future applications, or perhaps applications that you've started working on but are planned for the future? Where is it all going? You could give a few examples.
So one of the things we're working on now, and this is a PhD work of Natalie Lavi, is to extend the current ISO 19450 OPM standard to enable OPM to also do computations and things that are currently done only in programming languages.
Right.
And this is naturally embedded and incorporated into the current conceptual, basically.
כן. זה מיוט פשוט, לא?
לא עשיתם מיוט על זה?
לא עשיתי.
כן.
גם לא נלחץ לי.
אתה יכול פשוט להוריד את הווליום לאפס, לא?
גם אפשר, כן.
בצד שם, איפה שיש את
כן, כן, אבל לא עובד, לא עושה. יש הרבה פעמים שצפצף.
רגע, תנו לי שנייה נתלי.
על הטלפון חשבנו.
אתה יכול להתנתק גם מהאינטרנט, כי יש כל הזמן נוטיפיקיישן שקופצים.
כן.